Here we have Module 2, Part 4a, Calculations Series Circuit. We're going to use Ohm's Law, which is a relationship between voltage, current, I, and resistance. Once you know 2, you can find the third just by using these triangles. There's also an equation, whatever is easier. We're also going to use a multimeter, which basically measures the amps or measures the voltage loss as the circuit, the electrons flow through the circuit. Okay, so the first thing we're going to be studying is a series circuit. Series just means that when you look at the circuit, electrons have no choice but to go through the resistors that are placed in front of it. So here, when I press start on 4A, we're starting at 5 volts, and it always goes from 5 volts, goes into the resistors, back to the ground, which is what we're going to indicate with a black wire. So what we have here first is we have a multimeter, a machine that can measure either amps, the current, voltage, or resistance. If we're measuring the amps, it has to be within the circuit. So it goes into the machine with the red, and then afterwards comes out, and in this case the black part of the multimeter. And then we have the current going into a 0 ohm. So if I click on the resistor or I click on the tag, it tells me the resistance. And on top is, if you look at it, it's measuring the voltage, V, how much voltage is being lost at that resistor. So at 0 ohms, we're losing 0 volts. Afterwards, I click on this resistor and it says 1 ohm. This is the second resistor because it's the second one from the 5 volts, second resistor. And it's set at 1 ohms, and for some reason it's saying that it's losing 1.25 volts. Okay, and then afterwards comes out of this second resistor, the electrons then flow through the third resistor. The third resistor is 3 times bigger. Instead of 1 ohm horseshoe, it's 3 ohms. And notice that the amount of voltage that's lost, that's what's being measured in this machine, is going to be 3 times more than the amount of voltage being lost in the second resistor. And of course, in the first resistor, nothing's being lost because there is no resistance, which is set at 0. Afterwards, we put again another machine, a multimeter, measuring A, the current, amps, and notice it's the same throughout. The current is always going to be the same once you start the circuit. And that's because electrons can be thought of as cars on a highway. If 100 cars enter a highway, then 100 cars are then leaving the highway. You can't have a mismatch of these two numbers. 1.25 amps come into the highway, 1.25 amps leave the highway. As they go along the highway route, as they go along the circuit, they are losing voltage. And notice that the voltage, 3.75, 1.25, and 0, will always equal the amount of voltage lost in the entire circuit. So we started at 5 volts, we started at 5 units above the ground, 5 feet above the ground. Water flowing from 5 feet will eventually hit 0 feet. And it's the same with the circuit. And so you can think of it as a series of steps where no matter how high you are onto the circuit, the flow of voltage or the flow of water will always go back to ground or 0. Okay, so now we can answer the questions. What is the current at the beginning? Remember, the units are amps, so you're going to be looking at the circuit and seeing what this machine is saying. Make sure it's on amps. Anytime you're measuring it, it has to be on amps. And you could tell that before and after it's 1.25. And then afterwards, what is happening to the voltage as it gets pushed through each resistor? Voltage is being lost. As electrons pass through each resistor, some voltage is lost. Explain why there's no voltage at one of the resistors. And of course, at one of the resistors, you're going to actually have 0 resistance. So you're not going to have any voltage loss at that point. Okay, oops. Once a circuit is connected, does voltage or current stay the same? Current will always stay the same as it goes through a circuit. Explain how you can determine which resistor is the largest. The one that is losing the most voltage, you don't even need to click on the resistance, even though if I did, it would say 3 ohms compared to 1 ohm. You know that this one, the third resistor from the 5 volts, is going to be the biggest because that's the most amount of voltage that's being lost at this point. Total voltage always equals the voltage at the start. So if you start at 5 volts, you're going to lose 5 volts. And the total resistance of the Tinkercad circuit is 4 ohms. So if you added that all together, and because you added the 3 plus the 1, and you know that the total voltage is 5 volts, Well, now you can use Ohm's law, to tell you, using the triangles, that if you know one of the triangles, if you know the two of the variables, you can find a third. So here we have, they give us 5 volts, and they give us that the total resistance is 4. And so the only thing you don't know is I. So you just cover the I, and what you're doing is you're taking the 5 volts divided by the amount of resistance, the total voltage divided by the total resistance, and you're finding what I is. Okay, so actually it's this middle triangle here. If you want to use the equation, I'm covering I, and I have V over R, which means that 5 volts divided by 4 ohms gives me 1.25, which is exactly the amps, 1.25 amps, that Tinkercad gives us. So you can use Ohm's law and Tinkercad to get your answer, but of course on a test you'll only have Ohm's law. Okay, so that concludes 4A. Thank you.